Okay, so this is MA 110, the final exam review, and question number 8. And so we are asked and talking about here a population of wasp, and we're told that a population of coral wasp is 20,000. So when time equals 0, the population equals 20,000. So if I wrote that as an ordered pair of t comma p, I would get 0 comma 20,000. Then we're also told that when 18 months pass, so time equals 18 months, the population has grown from the 20,000 to 35,000. So if I wrote that as a point with time and population, I would get 18 comma 35 comma 1,000. So now I have 2 points. And then we're told that if the growth of the wasp population follows an exponential growth model, how many months will it take it to reach 44,300? So the exponential growth model looks like this. F of t equals ab raised to the x. And I should keep my notation consistent here. So I'm using t, so ab, not to the x, but to the t. And in the context of a population, the way I'm going to write this is population equals a times b raised to the t. Okay? So I'm told that my initial population, when time is equal to 0, I have 200,000. So let's do that one first. I said 200,000, but I meant 20,000. So 20,000 equals sum A, we don't know, times B raised to the 0. So I'm getting that from this first conditions we're told. T is 0, and the population is 20,000. So when I solve this, remember that this term, b to the 0, equals 1. And so I have 20,000 equals a times 1, or 20,000 equals a. So then when time equals 18 months, I have a population of 35,000. So now I'm going to use that information. So 35,000 equals, and then a, b raised to the t. A, b raised to the t, but t is 18 in this case. Well, we know from the first part that a is equal to 20,000. So let's plug that in. 35,000 equals a, which is 20,000, times b raised to the 18. So I just substituted a equals 20,000 in for a of that problem. So now I can solve this for b. So when I solve for b, I get 35,000 divided by 20,000 is equal to b raised to the 18. And so that simplifies to the same as 35 divided by 20, which is 1.75, is equal to b raised to the 18. And to find out what b is, we would take the 18th root of both sides. So b is equal to the 18th root, so I'm going to type that in my calculator. The 18th root of 1.75, and b is equal to approximately 1.032 if I round it. So Now I have my B, and I'm going to make this 18 nice here. I have my B and I have my A. So my population function in terms of time is equal to A, B raised to the T, but I know what A and B are. So my population function in terms of time is equal to A, which is 20,000, times B, which is 1.032 approximately, raised to the T. And this is my equation that describes the population growth for these wasps. So then the problem asks me how many months will it take for the population to reach 44,300. So the population is 44,300, and that's equal to 20,000 times 1.032 approximately raised to the T. And now my job is to solve this for T. So how do I do that? Well, I'm going to divide both sides by 20,000. So 44300, 44,300 divided by 20,000 is equal to 1.032 all raised to the T. And when I simplify the left-hand side, I get 44,300 divided by 20,000. And that's 2.215 equal to 1.032 raised to the T. And now I can solve this by maybe taking the natural log of both sides. 2.215 equals the natural log of 1.032 raised to the T, like that. And so then how do I solve this? Well, this would be natural log of 2.215 equals T times the natural log of 1.032. And to solve that for T, I get the natural log of 2.215 divided by the natural log of 1.032. That's all equal to T. So I type that in, natural log of 2.215 divided by the natural log of 1.032, and T equals approximately 25.3 months. So 25.3 months. And I can check this answer right here by plugging it in and see if I've solved it right. So I go back up to my equation and I type in that number. So 20,000 times the quantity 1.032 raised to the 25 raised to the 25.3, and that tells me 44,370. So it's a little over from estimating, but about 25 months is my answer.